Okay, so welcome back. So today I'm going to go through with you how to construct a simple ellipse using the concentric circles method. Okay, so first off, before we begin constructing our ellipse, we're just going to have a brief introduction as to how it is derived. So over here I've sketched out a cylinder object, 3D shape, and it's being cut at an angle by a sheet which I have sketched. And as we can see, it derives this kind of oval shape which we call an ellipse. Okay, so we can relate that to a rugby ball in real life or an American football, etc. Some buildings can form elliptical shapes at the tops of them, etc. So this is known as a conic section, and I'm going to show you how to construct this ellipse using the concentric circles method. Okay, so first off, up here we've got our major axis given to us, which is 120 millimeters, and our minor axis, which is 80 millimeters. So we have to straight away construct our major auxiliary circle and our minor auxiliary circle. So if the axis for our major is 120 millimeters, that means our circle's radius is going to be 60 millimeters. Okay, so I'm just going to move that out the way so we construct that now. So there is our major auxiliary circle, and then our minor auxiliary circle's axis is 80. So that means our minor auxiliary circle's radius length is going to be 40, which is half of 80, obviously. Okay, so there we have it like that. So there's our two circles drawn. Now our next step, which we're going to do, is we're going to have to divide this circle into 12 equal segments. So we're going to get something that will look like a pizza once you've it all sliced up equally. Okay, so at 30 degrees, which are 30, 60 set square, draw a line through your two circles, turn it around, draw another line the other way, then come up at 60 degrees, up like that, and the same the other way. Okay, so now we've got 60-degree line that way, 60-degree line that way, opposite ways, and 30 degrees that way and that way. And now we've got 12 equal segments between our two circles. Okay, so the next step we need to do now is we'll take the top half of our two circles first, so this half, so we'll ignore this half, and now mark off the points here. So what we can do now is from these points on our major auxiliary circle or outside circle is construct lines down like so, from them just down to about, so down to there and down to there. And then on our inside circle on the top half, we can mark off points there, there and there, and we draw horizontal lines out to meet our vertical lines, and they're going to create points on our curve. Okay, so we can mark those points now. So we've got a point here on the outside, point there, and it's the top of our ellipse, and there we have it. Now it's important to understand you do the opposite way on the bottom half of our ellipse. So we'll take the outside points again on the bottom half. That's the bottom point there. And there. So now we actually have to draw up the vertical lines upwards this time into our drawing. Up again, and you'll start to see the process emerging. And then the inside minor auxiliary circle, mark off our points and draw our horizontal lines out to meet them again. So there we go, and there we go. Okay, so I'm going to mark those points off in red again, and now you can see what's starting to form as a result. So now we can see our points are all formulated through this construction of our concentric circles method. So now I'm going to draw this in black. So what I do then when you're sketching the ellipse is focus on 3 points at a time. So we'll focus on the outer 3 points first and draw them nice and freely, like so, and the same this side. Just try and make sure to go through the ellipse if you can. And now the top 3. And the bottom 3. Through the red points if you can. And now you can join up the rest of it, like so. And the last one. Okay. So there we have our ellipse drawn through our concentric circles method. Next up, I'm going to do a different method of constructing the ellipse, maybe through the triangle method, and then I'll move on to the next conic sections, which is a parabola, and I will go through how to construct those and finding points for tangents on points outside the ellipse and tangents for points on the ellipse, and the same with the parabola. Okay.